Hey everybody, it's Al with BobCAD. So today I wanted to look at some electrode design, electrode machining. Basically, we have this model here, and there are some cavities that we want to work on. And these sections down here, we actually want to make an electrode out of in order to burn that into this cavity. Okay, so there's a couple of things we need to do in order to get this going. You know, as with anything, knowing what you need to draw or not draw, or what you need to do or not do, will either speed up or slow down your process. And, you know, depending on your experience level, that can be really frustrating. And, you know, I know it can be really frustrating for me sometimes when I'm trying to figure out how to do something and I'm just not really sure. But anyway, so let's take a look at this. So we have this this model here, and there's some surfaces that we want to identify. Really, that's the first thing we want to do, is we want to identify the surfaces we want to machine or create an electrode for, and that's going to be these surfaces here. So there's a couple of ways to do this. As usual, what I'm going to do is I'm going to select the surfaces that I want to work with, and I'm going to change the color of them. Now, you know, just kind of the nature of this this section here is there's a bunch of small, little, tiny sections, and these sections can be, you know, kind of problematic. Like this section here, there's like this little thing, and some of this will end up being blended in manually. Or blended in with the CNC, but I think that will be all right. Like this little lip here, that's, you know, a really tiny sliver. Look at this too. Look at this little tiny sliver here too. You know, so do we need to work with that? Do we not? I'm not sure at this point, but we want to identify the surfaces that we want to work with. From there, what I'm going to do is change the color of them. They're a different color. I'm going to create a new layer. I'm going to move that geometry that I've selected over onto its own layer, and then I'm going to turn everything else off. So this gives me the profile that I want to work with. Now, I'm going to end up burning out the profile of this electrode with the wires. So I do need to, one of the things I'll need to do is to extract the profile of it. So in order to do that, I'll create a layer and make it active, and then I'm going to do extract edges single. I'm going to project to Z0, and from here, what I'm going to do is I'm going to pick the edges around this model here. And this kind of gives me a profile. Again, you know, there's like little sections in here that are kind of ridiculous. So when you're dealing with sections like this, I mean, you're going to have to make some judgment calls as far as what geometry you're going to work with. But one of the things that's kind of nice is the extract edge and project to Z plane. You know, what this will do is it will flatten this geometry for me versus me having to project it down onto a surface. I can really just pick what I want to work with, hit my space bar, and now I have that profile. You know, and I'm going to use that profile to wire out my stock. Okay, now. Okay, so we identified our surfaces, we've extracted the profile we would use for our wire to get our profile for the part. The next thing that we kind of want to look at is filling in these surfaces, and this can be more, this can be kind of, you know, you have a couple of options, and this can be kind of frustrating too. So we have these holes in our surfaces here. And the reason why we need to fill them in is because we need to generate some toolpath to cut across this surface here. We want to cut across the surface and put some of the blending radiuses in here. And, these letters, we're actually going to come back and burn them into the part with another operation. So for right now, we're really just looking to get this clean surface. Now, there are some tools to clean this stuff up, or to fill in that area. One of the things we can do is we can untrim this surface. Now, when we untrim this surface, so we can go to surface and we can say untrim surface. It will give us our original surface. So you can see that's filled in, and that works out pretty nicely. So that would help for when we're doing our 3D toolpaths. But as far as this radius that we need to put on there, it's going to end up blocking that. So that's one way we can do it, is untrim it, and then we'll end up extracting wireframe and intersecting it, and trimming it away so we can plug these holes in. But let's look at actually machining these surfaces if we haven't filled them in, and then we'll look at some of our other options. So we have our part geometry here, and I really don't need to model that much more other than filling in these surfaces and cutting out my wire blank. I mean, I'm pretty much ready to go, so I can do my my stock wizard here. And with the stock wizard, I'm just gonna let it pick up the minimum maximum. Let's see here, Z minus. Let me add oh, that's the wrong way. Let me add just a little more material, just so we can show a little bit more of what's going on here. So that looks good. As far as our 0, I'm just going to 0 on the top, and then I just want to set my Z direction and my XY direction. So depending on how I'm going to hold this on the table, right now it'd be kind of in this orientation. So I might want to change my X so it's running this way, and let me flip my Y. So that kind of puts it like this. All right, so we'll choose OK. Now from here, I want to go ahead and start machining around the part. So I'm going to do mill 3-axis. I'm going to select all the geometry here. And I don't know, I'll use an advanced rough. Let me just set up a small tool here. This is fine. Just leave something on there. All right, and let's compute this. All right, so the first thing we see is, it's cutting around the part, and realistically, it's going down further than what we would need it to go. So I could use boundaries, but in this case, really, I'm just going to use a level, set it at 1/4 inch. So I have it cutting around the part and basically removing the majority of the material. We'll go ahead and run this through a simulation. Now, one of the things about the toolpaths that we're working on here is that if the tool if the tool doesn't fit in the hole, then it doesn't go down inside of it, So, like what we see here, the tool doesn't actually go down inside of where those letters are, So this gives us the rough shape for this, which is an okay start. Maybe we don't rough it, maybe we just run a planer and step it down. So, but let's go ahead and add another strategy here. We'll add the planer. So actually we're going to do advanced planer. All right, and then, we'll use a ball mill this time. It's fine. This is fine. All right, so let's go ahead and want to pay attention to extents. Let's do 3D extents in this example, and then we'll go ahead and recompute that. Let's blank this out. So one of the things that we're seeing is, the tool is dropping down inside of these holes here, and really, realistically, we really don't want them to, we don't want it to drop down inside of those holes. Okay, so this is one of the reasons why we're going to want to, we're going to want to fill those holes in. Okay, so let's tighten up our step over, for instance, and compute that again. All right, so now in one section here you can see it avoided the hole, and the other section you can see how it dipped down. The other thing too is, even though we chose 3D extents, you can see that it's not actually cutting over the edge where the radius is, which is what we would want it to do. So what we're going to do is say, we're going to say part bottom, but the same thing we did with the Z-level finish, we're going to do a bottom of job. And I'll just set this to 1/4 inch, for instance. All right, so now what's happening, is it's moving across the part, but it's definitely going down inside of these holes here, which we wouldn't want it to do. So, again, some of your options here is to, fill these surfaces in. We can extract wireframe for these surfaces, so we can do utilities, extract edges single, and let's just pick this face where it is, and then, so now we have these boundaries. From here, there's a couple of ways you can do this, but, let's make sure it's broken into some pieces here. We could do a cross-section surface for this, because again, we're going to come back and burn this lettering or this numbering in there. So that cross-section surface, that will fill that, should fill it enough so we can cut across it. This one here, I guess this is a little bit different. Let me see if I can get it to go from here to there, and then from there to there. Yeah, it didn't like that one. I might need to do this in multiple groups. This one I may need to create additional geometry. Like this edge here, I need to get another piece of geometry. So now I can do surface cross section. So I can go from here to here, and then I can go. Did I put the wireframe there? Let me do this. Just create another layer. And let's move that over to that layer. Alright, there we go. So now I can do another cross-section surface between here and there. It doesn't want me to do that, so let's try between here and here and here and yep. All right. So again, we're filling it in, and you can see that, this definitely takes some work. It takes a little bit of effort. It's not, that's not the worst thing in the world, but we have to go through and fill in those areas. Okay, so now that we've filled in those areas, we can come back and add that to our selection, and then we can recompute our planar toolpath. And when we do that, now you can see that toolpath is running across that surface. So instead of it dipping down inside of those holes, it's running across that surface. Now, some of the other options that we have. So this would be like a Mill Pro type scenario. Again, as far as for the Electrode design, really we just took the surface where it was. we isolated it, we created a boundary for our wire blank, we filled in some surfaces, and we started laying down toolpaths. So we didn't have a whole bunch to do there. But we do have other cutting strategies that are beneficial. If we take this same part here, what we may decide to do is to come in here and untrim this surface. So we have this surface here, so we could say surface, we'll say untrim surface, and that gives us this surface, right? So now instead of trying to do all the patching and everything else, we're going to come back and put the radius on it later. We might extend this a little bit. I'm going to do just a small extension on each side here. So what that will do is just basically get the part, if we look at where we're trying to cut, what it's going to do is it's going to get the surfaces off the edges, and we can run back and forth. Now you may say, oh, well, that looks like that's breaking through. There is a rendering tolerance for the drawing, which is by default is turned down. When you start getting into smaller shapes like this, you may turn your render or shading quality up, so that way you can see that it's actually fine. Okay, so now from here, what I might do, I could use advanced planar, or what I'm going to do is look at yeah, we could do an advanced planar. Well, let me do another one. So we'll do mill 3-axis. We'll select just this surface here. All right. From here, we can say advanced planar, set our tool size, set our parameters, set our tolerance, go ahead and compute that. It's talking about my top of job. Basically, you can see when I extended this, it broke the threshold for the stock. So what I want to do is just bump my top of feature up. And then now we can see this tool path running across that. So that will give us a nice clean finish. We could run this way, we could run across it. You could do either option there. Okay, so that would be like another option as far as how to fill that in. If we run it along this surface here, now we need to come back and let me undo that. Now we need to come back and figure out how to machine these radiuses here. So there's a couple of ways to do that as well, and this is where really we start talking about the multi-axis toolpath options. Let's go ahead and just look at parallel cuts real quick. I'll go with this ball mill here. So parallel cuts, we're going to pick our drive surface, which we're going to say is this surface here. We're going to set our direction. This is going to be a 3-axis cut, and we'll compute it. Alright, so first thing that we'll notice is that it's cutting on the wrong side of the surface. It's actually cutting on the bottom of the surface here. So what we want to do is reverse our surface normal, and we just select this face here, and you can see the surface normal is now going in the proper direction. We'll go ahead and reselect this. So we'll go to our drive surface, reselect it. And then we will recompute it. Now you can see the tool is running on the top of the surface there. Now let's tighten up our step over quite a bit. So let's make this, all right. And we'll recompute. So now we see a bunch of toolpath motion. But the thing is that we're skipping over these holes here, so we have the same problem. We also have a lot of clearance moves, so we're gonna get rid of those too. But what we would end up doing is saying, let's adjust this. Let's make it two-way cutting. So we'll do zigzag. And by doing zigzag, we have it cutting in two directions. And then now we want to start defining what's happening on the with these holes, these gaps along the cut. So when you get into your link option, you have gaps along a cut. So if it's small gaps, it does a direct move. If it's a large gap, it does a clearance move. Now, one of the things we can do is a direct move would mean it would just link to that surface. So we could make this, let's say 300% of the tool, compute, and then now you can see how it's starting to just link or connect where those holes are, but you also see some clearance moves as well. Okay, so we want to talk about how to get those down. But this is one thing we did there, is we just had it just by changing that gap size, it is updating those holes, and it's just cutting right across it. Okay, so that's one thing. The other thing we can do here is when we get into our links, it says large gaps retract to clearance. So I'm going to do follow surfaces for large gaps and recompute that. Okay, so that will help fill in some of these other areas, and then we're going to continue to just dial this in. Let's say links between slices, small moves is direct, large moves is retract. So we're going to again bump up our percentage of our cutter, and now you're going to see how it's starting to drop back down. But we don't want, these big clearance moves here. Again, this is just a bunch of wasted time. So what we're going to do is change this a little bit more. Let's try 1,000%. That brings them all down except for just a few of these here. So we're seeing we still are getting some clearance moves, but we're able to drop these down. Now this hasn't rolled over the edge of the part yet. Really all it's done is machined across this top surface here, but instead of having to plug in these surfaces, we've just told it to machine across it. Okay, that's a big advantage of the surface-based toolpaths, is being able to control the gaps and also the links, and really allow you to dial in your cutter path. Okay, now as far as for this next section here, we're going to have to pick that up in the next video. Hopefully you guys found this information useful and helpful. I'm sure you're going to have some questions about the advanced surfacing. Please comment in the video below. If you like the video, let's get a thumbs up. Otherwise, we'll see you in the next one. Thank you so much, guys.